Dear friends, we are now going to see the program as functions, how to see the deletion in a binary search node. So we have explained the three cases in which deletions take place. Now we are going to see how it can be done. So this method or program or function or algorithm, what it does, it takes a binary search tree, let's say T, and looks for a node to be deleted, and using the method of deletion discussed before, either a leaf node or a node with a subtree or a node having both subtree, and having deleted and replaced with the correct value, the resultant tree is returned. So this is the functions. So we have put two parts here. This is the deletion part. It calls a function to find out the smallest, that is find a minimum, and this is another algorithm which may be useful for you searching for a value in a binary search tree. So either find or less. So it's a combination of few things. So I'll just explain. This is a deletion. Now given a binary search tree, this is sometimes a short function that can be asked. Find the biggest, find the smallest. So we know when you get a binary search tree, the biggest value always to the rightmost. So if you want to find the biggest, go till the rightmost till it is null. And if you find the smallest, you go to the leftmost till it is null. Next is null. So that is how we search for the biggest and the smallest. Then searching for a particular item in a binary search tree, that is this, just I put together. Now given a binary search tree, if I want to look for a particular item, say k, suppose 3, then comes here, root, check the value, it is less, so go to the left, come here, look at the value, 3 is greater than this, so go to the right, so you find it here. Suppose item was not there, suppose I was searching for, let's say, just a value called, suppose 3.5, okay, so less than 4 comes here, greater than 2, 3.5 comes here, 3.5 is greater than, comes here, so there is null, so the item is not found. So those are the two possibilities. So either you traverse to the left or you traverse to the right based on the value of a particular node being searched and against the value being searched, either bigger or so. Okay, let's now come back to the deletion algorithm. So here is a deletion part. So let's say I am going to delete a node having the value k from a given tree T. So the first possibility, suppose T is null. That means if I get a null tree, then my resultant tree is T, a null tree, the T itself. So I'm returning T. Next, now I'm going to search for an item. Suppose I want to delete 1, it's a leaf node. Then I'm going to use the same searching algorithm. That means 1 is less than 4. So keep on traversing left till it reaches here. When I reach here, okay, so this is how it traverses. So if it is less, it goes to the left. If it is greater, goes to the right. Forget this. This is when case number 2 actually here. This is case 2. Then comes here. So this is a node to be deleted. Then it matches. It is neither left nor right. That means this is a value. So this becomes temp. Okay. Then T left is null. That means I'm going to replace this node with its left or right. Now in this case, both are left and right are null. So T will become T's left, that is null. That means T will become null and that will be returned. So this will become null. So that is a case when a leaf node is being deleted. So you can understand this, and this free temp, this node is removed by this command. The other case of, suppose I want to delete 5. What happens? The algorithm works in the same way. It comes here 4. So it goes to the right. When I go for right, again, next recursion, it will look for is 5 less than this value 5, not less, not greater, which means this is a value. The value is 5 to be deleted. So then this becomes temp as before. Then T left is null. That's the first part. If T left is null, so T becomes T's right. That means now this is T. What will be returned will be this. So this gets connected to the previous node and this temp is removed, which means when I return T back, what is getting returned to this node? So 4 rights will now point to 6. Okay, so that is deleting. The second case, deleting a node having. Similarly, if it was a left subtree, the right would get connected because you have both the options here. Now let us look at the third option. That is when I'm going to delete 2. So 2 is less than 4, so it will come here. Now is 2 less than 2, that is k that is coming, not less, so it will not go to the left. It is not greater, so it will not go to the left, which means here it matches with this case, that is both. So this is when node has got left and right subtree. So it has got a left if t left and t right, that means both are not null. So this is true. Then what happens? Temp equal to find a minimum of t right, that means this is t. It will go to t's right and find out the minimum from the right. So we are using the right minimum algorithm. Okay, that is a common practice. So we'll find out the right minimum. Let's imagine the right minimum. You may have more values, as I said in the other session. So here right minimum is 3. So 3 is taken. So it will find the value, the node having the minimum value. Then t data becomes temp data. That means this is temp, this is the smallest node. So this data gets replaced here. This is t. That means 3 will come here. Okay, 3 comes here, and then it calls the delete tree. Now 3 has to be deleted, has to be removed. So it now deleting this node is nothing but deleting a leaf node. So I have replaced the value here and I delete this node just like deleting a leaf node. So calling t data now is the value 3 and with from the t right tree. So this will work like before and return the tree, and this would become null. So what happens, my resultant tree would be 4. Now 3 would come because I go to the right and find out the minimum, and I get a resultant tree. So kindly go through this. Of course, this is not actually replacing the node. We are replacing the value and deleting. So this is one common way of doing it. I think the algorithm is simple to understand. I would ask you to work a little on these type of algorithm. That means finding the biggest for a given tree, finding the biggest on a right tree, finding on a smallest on a left tree, finding the smallest on the tree given, or counting the number of nodes, searching for a. This is a common program asked for practicals. So you have to create a tree, also search for an item. So if you look at this algorithm, I'm returning a value if the item is found. For example, if it is not found, this is where it would come. I'm returning -1. If it is found, I can either return the item searched or return 1, whichever way you want. That's why it is given as this. So this could be some of extra works that you can work out by yourself and search, or take a binary search tree, look for a particular item, or search for how many number of nodes are there on its left subtree, how many nodes are there on the right subtree, counting, etc. I think it will help. So this often comes as a theory question, searching as practical mostly, but deleting different scenarios and sometimes along with practicals. So deleting nodes, what are the cases? It could be a theory question. Thank you.